We're doing data structures basically, and we're starting lab 11, searching and sorting. In this session, we'll keep it quite short. I'll explain the questions to you, and I will uh, explain the answers to you as well. I'll show you all the answers, and I'll walk you through all the code, and I hope it would help you understand and solve the questions earlier on. For the first one, you can see uh, the questions, right? The first question is all about selection sort. You sort a ordered list by values by repetitively putting up a particular value into its final position. The search strategy is as follows. Okay, selection sort. Okay, so what I'll do now is actually show you. So we have insertion sort. Okay, selection sort smallest, selection sort largest, selection sort selection. Okay, that's it. So selection sort. If you come here, you can see selection sort. Before I explain the selection sort, I need to show it to you. So I will show you what it looks like. So what you're doing is you're inserting a number as it goes. So you took 7. Let me find a good animation for you. Okay. So as you can see, what you're trying to do is you're trying to find the number after 5, the closest one, and then you're swapping um, those numbers. Right, so what you're doing is basically you're trying to find the next uh, closest number, and then you swap that until all the numbers are sorted. how do we do this in code? So this is what it looks like. You can see how it's going. So you started the first one, then you look at the second one, you replace the next token basically. So you would add 6, you found the next smallest number, you put it there, and then you keep finding the next smallest number, and you replace the current number with the smallest number of that. Okay. So if you look at the code here, it's quite straightforward. So we have this sort class, right? And in this, we start from 0, we go to the length of the array, that's fine. And then we have the other loop. So obviously we have, if we have 10 elements, we're doing 10 passes. And in each of those passes, we're trying to find an element that is smaller. Well, which is the smallest? And then we're swapping the current element with the smallest element in n minus 1. So let's say if you're on the nth pass, I'll just draw for you. If you're on the nth pass, that's it. To let's say 8, 1, 2, 3, 4, 5. So I start from here. I'll scan all of these. Okay, so in n minus 1, I'm at 1 right now. So n minus 1, this is n. And so therefore this would be this one is basically n minus 1. This is n. Okay. So 8 is something smaller here, 1. So I would take that with 1 here. Okay, so I would replace those, swap those. I have 2, 3, 4, 5. Then I will do the same thing. 8, 2, so I'll get 1, 2, 8, 3. Actually, yeah, I would have to keep doing the same replacement. 3, 8, 4, 5. And then 1, 2, 3, 4, 8, 5. So in each of these, you're actually swapping certain elements. 1, 2, 3, 4, 5, 8. Now, if you see this, if ascending true, index equals main index, else index equals max index. Okay. Now, let's try to run this. Let's see. So we have the two nested for loops, and we check. And this one is actually for the swap. True if yes, 1, otherwise minus 1. Mhm. Now, what I want you to do is I'm showing you the code right now so that you can implement it yourself and try to experiment it. I'll be showing you some other code as well. I'll show you a large variety of different kinds of sorting algorithms, and your job would basically be to implement all of these, experiment with all of these. Your uh, lab assignment only asks for, well, your lab questions only ask for the sorting with selection sort, but I want you to try um, the insertion sort, bubble sort, etc. as well. I mean, you've done bubble sort for so long now that you'll have to try other things like quick sort, keep sort, etc. Okay, so this is the code for selection sort. Okay, and as you can see, what we're doing here is basically finding the minimum index. Okay, the number that has the smallest index. You start from n plus 1, right? So n is I, that's the number of pass. Well, you start with uh, from I plus 1 basically, or n plus 1 or I plus 1. So if the first loop, these are the passes, right? You are maybe here, 1, 2, 3, 4, 5. So I'm at the first pass, I would start looking from here, actually, right? I would find the smallest number, uh, and then I would put it back. Yeah. So I would have to find the smallest number to replace them. So we compare, and if it's less than 0, then index is equals to j. So if the comparison of that position compared to uh, the index that we're comparing with, so we're actually including the I as well. So if you're in the first pass, or let's say in the second pass, if you're on the second pass, you are comparing each of these and trying to find the smallest number. If you find something else from after it, like after I, that's I. So if you find something else, I plus 1, which is j, you would put that here. So I found 2 in I plus 1, okay, until n, which is the length. If I find something, then something smaller and smallest, I would replace that. If this was 2, then there's no replacement needed. But yeah, so this would become 2, this would become 6. And yeah, so now if I continue, so I of 2 is done, so I would now be 3, and then I would have a j of 3 plus 1. So now I'm comparing 6 with all of them, all the values, right? And if compared to index is less than 0, so it's smaller. If it is, then I have to uh, swap, otherwise the index would not change actually. The index would stay that. So you don't do a swap actually. So if you see here, it does not change because there is no smaller number. So the index would remain I and you just replace well, 6 with 6 and nothing happens. That's what happens here. And we won't replace 6 with 6 because that would just waste our resources. You can see if the 6 is equal to 6, if they check the index is equal to I, then we just skip the swap. So it's very straightforward. Let's try to run it. So tester and main.java. So in main.java, you have selection sort smallest, selection sort largest. Okay. So if you have ascending, descending order. Because and basically you're trying to find if you're trying to sort it in descending order, you have to find the biggest number. If you're trying to sort it in ascending order, then you have to find the minimum number. Now, if you look at the other one, the last one, that's insertion sort. I'll just show you the code for that as well, and I think that should be about it. Is ascending, right? So this is where it checks if it's ascending or descending. It's just basically the opposite. All you need to do is you have to find the biggest number to insert rather than the smallest number to insert. Okay, so I will show you the uh, animation for this as well. We have 6. Let's insert 6 after 5. So I have to find a smaller number than 6. So as you can see, you're taking the number, okay, and then you are inserting it in the right position. You take 7 and now you just insert it. So you will have to insert it between 6 and 8. So when you find a bigger number, you just put it behind it. So so when you find a smaller number, you put it right after it. So 3 is still bigger, 1 is smaller, so you put it after 1. 4, so again, 8 is bigger, so you keep moving on. 7 is bigger, 6 is bigger, 5 is bigger. And then you see 3. 3 is smaller, so you just insert it there. And that's basically insertion sort for you. It's very straightforward. I want you to practice and experiment with these and try to write the code yourself. Please do not use AI for writing the code. Use AI to help you study, but do write your code yourself. That's a big thing that will help you for now. Use a lot of AI for understanding how can you use AI. What is the best way? The best way would be to create exams for you based on your slides. So ask AI to make MCQ question papers and let's say make flashcards and revision notes for you. I would not recommend notes, but I would say any question answering way where you have to answer the AI, not the other way around. If you have to answer the AI, then you'll quickly realize how much you actually know and how much you've studied versus how much you're just, cheating by getting the answers directly. So don't get answers directly. Just try to do it yourself and then compare. Compare and match your answers to grade yourself. And it's okay if you can't do it. It's better if you can't do it rather than do it by just getting the answers because this is practice, right? So inshallah, in the final exam, you would be able to do it. So the code for insertion sort is here. It's very straightforward. You just find something smaller, and then as soon as you find something smaller, you insert. So if you keep finding bigger, you keep going, and when the item which you're finding is not bigger, then you insert. Done. So I think that's all. But I'll just show you the code for, well, this is the classic bubble sort. You guys should know this by now. And then this is the heap sort. Heap sort. Okay. Now I want you to try all of these. I'm showing you the exact answers. That means you can literally write the code yourself. Mid sort is very interesting as well. But you will have to, go through some tutorials on this. And if you get stuck, you can just ask me. Every sorting algorithm has a toString and has, well, a name obviously, but then you also have basically you're implementing or what you're doing is you're extending the sort method. Pretty straightforward. This is an alternate method, an alternate implementation of the same method, and that's it, I think. So that's all for now. You guys can understand and try to replicate the code yourself. make sure you write the code and try to replicate it. If you can get the answers, the same answers as me, let me run it for you as well. Uh-oh. Okay, so it runs. You can see the output. Very straightforward. So make sure you ask me if you have any questions, if you have any doubts with the group assignment. It's online right now. So I hope you're studying for your finals. I hope you are practicing a lot of lead code and things like that, because data structures is a tough course and the exam can be a bit tough as well. So I hope you don't have to repeat the course, but I'm 99% sure that you will not have to repeat the course. So don't worry about it. Just do your best. That's all for now. Take care. Goodbye.